All right, guys. So for today, we're going to hopefully finish this packet of notes today. So we did simplifying just a single radical. Yesterday we worked on multiplying and then simplifying. Today is going to be dividing and simplifying. But there's another extra little rule in there with dividing, because mathematicians have weird rules sometimes. And we'll talk about that kind of weird rule today. All right, so with radicals, if they were separate, I could multiply them, right? As long as they're underneath the radical. Same thing's kind of true with dividing. I can split them. So if I have like a radical 3/4, you guys hate fractions, right? So I'm allowed with a giant radical, and I actually suggest you do this first. If you have a big radical, split it. So that radical's on the top and the radical's on the bottom. So fractions really aren't that bad. You're like, oh, it's the square root of 3/4. Well, you're like, well, you just do them separately. Square root of 3, I can't do anything with. Square root of 4, it's just 2. So it's radical 3 over 2. Okay, so giant radical, we want to split them into two separate ones. All right, so number 1, square root of 16/49. So first thing we want to do is split it. Square root of 16 over the square root of 49. The other reason I make you guys split them right away is because sometimes people forget that a giant radical actually goes to the top and bottom. And they just use it on one part of it and not the other. Okay, so radicals we want to split. What's the square root of 16? And the square root of 49? So it's just 4/7. Does that simplify at all? No. No, it doesn't. All right, so number 2, again, first thing, split it. I see a giant radical. I'm going to split that to radical 2 over radical 81. Square root of 2? Can I do that? If I do a factor tree on it, do I find any pairs? No. That's just 2 times 1, so there's nothing there. So that's going to stay radical 2. Square root of 81 is just 9. Now, one thing I see students do all the time, and it drives me absolutely crazy. The students will go, square root of 81 is 9. They're like, oh, and then the square root of 9 is 3. And they just kind of keep going. When you go to the bathroom, what do you do with the toilet paper when you're done going to the bathroom? You flush it, right? That's disgusting. Are you going to put it in a little bowl next to the toilet and use it again the next time? That's how I feel, that disgusting ew that just came out of some of you when you do that with a radical. You don't reuse it. That's gross. So I'm not going to use this radical on the 81 to make 9 and then reuse it and make that a 3. That is disgusting. So at some points when I walk past you and I'm like, reuse toilet paper? Gross. You're going to know what I'm talking about, right? You reuse that radical. That's disgusting. I'm not calling you reuse toilet paper. I'm just saying that you did reuse. That's really gross. Everybody got that visual in your head right now? Like, that's disgusting. All right. The more visual that is in the head, the more likely you are to remember every time you're like, wait a minute, am I reusing that? Don't do that. Okay? All right, now that that's all stuck in your head. All right, number 3, the square root of 8 over 25. All right, that's a giant radical. We want to split it. Square root of 8, square root of 25. Square root of 8, is that pretty? But it splits. I can do, good, so I'll do my quick factor tree so we can see that. But yeah, it's going to be a pair of 2's outside, and you have a leftover 2, bless you. Good, and the square root of 25 is just 5. Okay, so when you're looking through these things, we need to make sure that we're looking for splitting our radicals. Obviously, we look for the pretty ones that kind of jump out to us. And if they're not pretty, can I do a factor tree and find some pairs? Okay, that's what we're always looking for. All right, so far, not so bad, right? But in math, there's sometimes just those weird rules that they just kind of throw out there, and you just kind of be like, okay, I got to do this rule. It's kind of what we do in math. This is one of those times. All right, they say in math that if you have a radical in your denominator, so on the bottom, it's not simplified. It'd be like leaving 4/10, not simplified. Same thing here. If there's a radical in the bottom, it's not simplified. So we have to get rid of it, and it is called rationalizing the denominator. Whew, it's a big fancy term, right? You'll find in math, the harder something sounds, the easier it actually is. And stuff that sounds like it should be super easy, you're like, oh my god, that is really hard. Okay, it's kind of opposite. So let me kind of show you what's going on with this problem. So right from the start up here, radical 4/3, what we just worked on, we're going to split that apart. Square root of 4 is 2. Square root of 3 I can't do anything with. But since there's a radical in the bottom, it's considered not simplified. So then I want to go ahead, this is the same problem just brought down here. Whatever the denominator is on the bottom, you're going to multiply top and bottom by that, whatever that radical is. So then top and bottom, if I multiply the top and the bottom by the same thing, have I changed the value of it? No. It's kind of like when you multiply, changing denominators, multiply top and bottom by 4, multiply top and bottom by 3, whatever you're doing. Okay, so what's 2 times radical 3 is 2 radical 3, outside number, inside number. They don't multiply together. And then radical 3 times radical 3 is radical 9. And what's the square root of 9? It is 3. So then I end up with an answer that is simplified. Okay? There is no radical left in the bottom. Now, if I would check in my calculator, are these two things going to be equal to each other? Grab your calculator and try it. 2 divided by the square root of 3, and then 2 times the square root of 3 divided by 3. Are they the same thing? They're the same thing. If I would type in 4/10 and 2/5, are they the same even though they look different? Yeah, one's just a simplified version. Now this one almost looks like you made it more complex because now there's more pieces than there were to begin with, but it is actually a simplified version. Okay, so whatever that radical is on the bottom, you're going to multiply top and bottom. All right, so let's go ahead and try some. So number 4, I have 7 over radical 5. So I don't have any radicals to split, right? And then square root of 5, is that perfect and pretty? It is? You type it in your calculator, you get a pretty answer? No, that's not pretty. Can I do a factor tree on the 5? Find some pairs? I'm trying to talk you through the process that you should be kind of running through your head every single time, okay? Split your radical, try to simplify your radicals. I can't simplify a radical 5. And then I can't leave a radical in the bottom. So we're going to multiply top and bottom by radical 5. Right? Same on top and bottom. It's considered balanced. It's okay. I didn't change the value. 7 times radical 5. 7 radical 5. What is radical 5 times radical 5? It's radical 25, which is just 5. So I have 7 radical 5 over 5. Ooh, can I cancel these 5s out? Good. One's under a radical, one is not. They are not allowed to be canceled. What if they were both under a radical? Yeah, then I could, right? Or if they're both not under a radical, yeah, you can cancel. But one's under, one's not, I can't do that. All right, what about number 5? So go through your steps. Do I have a radical to split? And you have a big radical? A big tall one? No, I don't have a big tall one. Okay, so I have a radical on there, though. Can I do a factor tree on that? Find any pairs? No, that's just 2 and 3. Okay, so then I can't leave a radical on the bottom. So we're going to multiply top and bottom by radical 6. So what's 6 times radical 6? 6 radical 6. Radical 6 times radical 6? Radical 36, which is just 6. Very nice. All right, just make sure we're okay. Radical 6 times radical 6 is radical 36, which is just 6. And then these two 6's that are not underneath the radical, those cancel. So I am left with just radical 6. Cool. Does anybody else find it very interesting, though, that the beginning problem and this actually mean the same thing? Is that not weird to anybody else? 6 divided by the square root of 6 is the same thing as just the square root of 6. Isn't that weird to anybody else? To me, that's very weird. All right, number 6. All right, my radical's already split, so I'm good. Can I do a factor tree on either one of them and find pairs? No. Am I allowed to leave a radical on the bottom? No. All right, so what we're going to want to do is multiply top and bottom, because the bottom radical is my problem, right? The top I don't care about. The bottom one is the problem. What is radical 10 times radical 3? That is radical 30. Radical 3 times radical 3, and that's just 3. Can I divide 30 divided by 3? In this problem, can I divide them? No. Why not? One has a radical, one doesn't. Okay, so they don't intermix. Can I simplify radical 30? Is there any pairs in there if I do a factor tree? Is 6 and 5 a pair? So remember, when we're trying to simplify, I'm looking for pairs. If I have 6 and 5, that's going to be 2 and 3. Any pairs? No, there's no pairs. So then I'm actually done right there. But you want to check, because sometimes when you go to rationalize your denominator like that, it ends up with a number up top that you're like, oh, wait, now I can actually simplify that, and you can move a little further. So what I try to help you guys make things as easy on yourself as possible. If the numbers are smaller, is it easier or harder? Easier. What happens when your numbers get huge when you're doing factor trees? Your factor trees get huge, right? It's a lot harder. So my suggestion for you guys, I would say at least 75% of you will not listen to me. And you'll get mad at me later when I tell you to do it the easy way, and then I'll show you and you'll be like, oh, I forgot. Simplify everything first. If your problem simplifies from the start, none of these have yet, simplify them first, okay? And we're going to look at some as we kind of keep going through here in a little bit. All right, so number 7. Does anything simplify first? Just kind of get that stuck in your head. Does anything simplify? No? Okay. All right, so square root of 2. Does that do anything for me? Square root of 15, any pairs in that? No, so I can't really simplify anything. All right, so I can't leave a radical on the bottom. So I have to multiply top and bottom by radical 15. So on the top, what is 5 radical 2 times radical 15? Good. 5 radical 30. Right? The outside numbers and inside numbers. That's kind of what we're working on. On the bottom, radical 15 times radical 15. I appreciate some of you have learned to skip that stuff. It is radical 225, which is just 15. Just to make sure we're okay. Eventually, I'll stop writing that step, but for now, I just want to make sure you see where that's coming from. All right? And then does anything simplify? Yeah, the 5 and the 15, I can divide them both by 5. So 5 divided by 5 is 1. So 1 radical 30. And then 15 divided by 5 is 3. Do I need the 1 out front? No, you wouldn't have to. If you want it there, that's fine, but you don't have to. And we just looked at the last problem. Radical 30 doesn't break down to any pairs. Question? Yes. I know it's coming in future chapters, so I don't want to necessarily word it that way, but yeah. Yeah. I just know what's coming, so I'm trying to, yeah, okay. All right, number 8. What should we do with that one first? It doesn't simplify. Say it again. Break it. Yeah, I got that big giant radical. Let's split that. Radical 5, radical 14. Yeah, we want to split those apart so we don't lose track, but there are technically 2 radicals there. All right. You know what? Either one of them simplify? Can I do factor tree on either one of them? No. All right. So no. I can do 14 becomes 2 and 7, but there's no pairs there. Am I done? Multiply by 4. Why do I multiply by radical 14? Yeah, you can't leave that radical on the bottom. Good. So what is radical 5 times radical 14? That is radical 70. Radical 14 times radical 14. Humor me. Becomes radical, is it 2, no, 196? 196? Oops, 70. That becomes 14. Am I done or can it keep going? Why am I done? I can't break down 70? There's no pairs, right? 7 and 10, 2 and 5. See, there's no pairs. Because that is probably the biggest thing students say is they're like, I don't know when I'm done. Like, when do I stop trying to do stuff? If you look at your problem and your radicals, if you break them down, there's no more pairs, you're done with that part. If you look top and bottom and there's not outside numbers that simplify, or there's not radical numbers that simplify, like, you're done. Okay, some people are like, well, I got to keep going, right? No, sometimes you hit a point, you're just done. All right, once you guys tried number 9 on your own, and we'll see how we do. Okay? Remember, what was my suggestion to make your life easy? Simplify first. All right, guys, so on number 9, first thing, you have a giant radical. Make sure you're splitting this. So radical 27 over radical 8, split the radical apart. And then my suggestion to you was to simplify first. More of you actually simplified than I thought would, so that's good. So 27, I can simplify that radical. All right, that's going to become 3 radical 3. The bottom can simplify. A couple people were only hybrid people here. They like simplified the top but not the bottom. So that one's going to become 2 radical 2. So if you simplified first, look how small your numbers are. They're all 2s and 3s. It's kind of nice. But the problem with that answer is there's still a radical on the bottom. So when you multiply top and bottom by something, is this 2 outside, is he a problem? No, just that radical is the problem. So I'm going to multiply top and bottom by radical 2, because that's the part that's the problem. So on the top, what's 3 radical 3 times radical 2? 3 radical 6. We'll go back to kindergarten basics later. On the bottom, I have a 2, and then I have radical 2 times radical 2. It's radical 4. What's the square root of 4? Times 2 is just 4. So I get 3 radical 6 over 4. That's all right. Now, some of you said, I'm not simplifying, and you just went right for rationalizing your denominator. Now, in this case, not terrible. Like, if you kind of look through it the other way, you would have multiplied top and bottom by radical 8, which would have given you, is it 216? Over, would have had an 8 there. And then you have to do a factor tree on the 216, which ends up at, yeah, it ends up huge, right? So 2 and 108. 108 is 2 and 54. And then that's 2 and 27. 3 and 9. 3 and 3. So then you got a pair of 3s and a pair of 2s. So that's 6. Left over, so that's 6. Then you get an 8. And then you get a 6 over 8, which needed to be simplified to make it 3 over 4. So, I mean, it was a 216. It wasn't terrible to deal with. But I know, like, the kind of problems that will come at you later. What happens if you have, like, I don't know, 103 on top and, like, your bottom number is, like, 507? Like, you don't skip it. But, like, if you didn't simplify first, when you would multiply those together, your numbers would get huge. Okay? Simplify first. It's going to make your world a lot easier to deal with. Okay? How are we feeling so far? Okay? You guys ready for a brain break? All right, guys. Number 10. Square root of negative 63 over 52. Well, right out, what's the first thing I should do with it? We should split it. And then what? I, yeah. Are you guys cool if I split it and take out the I at the same time? Yes. All right, well, good, because I'm lazy. I don't want to write it too many times. All right, so we're going to take out the I, square root of 63, over the square root of 52. Okay? So, guys, I know some people work better if they have step-by-step directions. I know there's a few of you in here. Let's kind of step this out. So the first step that we're doing is split your radical, right? So a split radical and take out I. We kind of did that all at the same time. We split the radical and we took out the I. Not take out your I, the I. All right? Your second step that you want to try to do is to simplify radicals. Now, when I say simplify radicals, what am I asking you to do? Factor trees. So make a note if you need it. Factor trees. That helps you remember what you're supposed to do. So can I do a factor tree on those? Yes, I can. 63 is what? 3 and 21. And that's 3 and 7. So I have a pair of 3's that come out. So I'm going to have 3I, and my leftover is 7. What about 52? I know that's, yeah, 26 and 2. That's 2 and 13. Girls? Perfect. 2 radical 13. All right, so that was step 2. I simplified my radicals. Because stop and think for a minute. I'm not going to do it this way. But what if you were one of those people like the last problem who went, I'm just going to rationalize it first. And you multiplied top and bottom by radical 52. 52 times 63, your numbers were getting big. Okay? My numbers stayed a lot smaller this way. All right, what would be your next step? Get rid of that radical. What's that step called? What's the fancy math terms for it? Rationalizing the, what's it called? What's the bottom of a fraction called? Denominator. Rationalizing the denominator. All right, which means I need to multiply top and bottom by radical 13. So what is 3I radical 7 times radical 13? Good. 3I radical 91. What is 2 radical 13 times radical 13? It doesn't matter. It does matter. Well, what's radical 13 times radical 13? Radical 169, which is just 13, times the 2 that's already here. So it's going to be 26. So if you want to see the notes there, what I was doing, I was 2 times radical 169, which is 2 times 13, which is 26. If you're comfortable to jump right from that to that, that's fine with me. Okay. All right, after you rationalize, then what should I try to do one last time? I can't necessarily always do it, but what should I try? I should try to break down my radical, and I should try to simplify, right? So I'm just going to write simplify. You guys cool with that? So sometimes you can, sometimes you can't. In this case, 3 over 26 doesn't simplify. Radical 91, that's just 7 and 13. So there's no pairs. I can't do anything. So I'm actually done here. But you always want to try to simplify one last time at the end if you can. Sometimes you can, sometimes you can't. All right. Number 11. Negative radical negative 36 over 40, radical 48. So step 1 is to split my radical and take out I. Well, the radical's already split. Do I have an I to take out? Yeah. So I'm going to have I, negative I, radical 36 over radical 48. Right? Because if I take out that I, there's already a negative out in front. So that's why it became negative I. Okay, that was step 1. Step 2 is to simplify my radicals or do factor trees. Can I do factor trees on them? Or can they simplify nicely? Yeah, the top one's just going to be, so what am I going to write? Negative 6i. Right, because the square root of 36 is 6, and I have a negative I, so negative 6i. Radical 48 is not pretty, so we can do a factor tree. We'll do a factor tree on that one. So a pair of 2's gives me 4, and I have a radical 3. Yeah, you could. I'll probably wait until I simplify again at the end, but yeah, you absolutely could. All right, step 3 is to rationalize my denominator. Do I need to do that? Yep, I got a radical in the bottom. So let's multiply top and bottom by radical 3. So we have negative 6i radical 3. What does the bottom become? What does this become? Let's go step by step. What does that become? It becomes 4 radical 9, which that makes that 3. So it's just 12. And then step 4 is to simplify. Does anything simplify still at the end? Yeah, the 6 and the 12. The fact that one of them's negative, don't care. The fact that the one has an I on it, don't care. Right? If it's being multiplied, they don't have to be like terms. So we can go ahead and just simplify. 6 over 12 becomes, it's negative half. So we have negative 1i radical 3 over 2. Just cleaning up the 6 over 12 is half. If you want a 1 in front of your I, you can. Won't count you off for that. But I'm just lazy and don't want to write it. How are we feeling so far? We doing okay? Follow your steps. That's the biggest advice I can give you. Do things in the right order. All right, one problem to go. Let's see you try it. All right, guys, let's go ahead and talk through 12. I will do it first the way I think the majority of you did it, and then I want to show you another option. Okay? So first step is to split your radical and take out the I. Well, it's already split, but they actually both have an I, right? So I'll have I radical 40 over I radical 6. If I have an I on top and an I on the bottom, combine them how? And do what with them? They had cancel them, yeah. Top and bottom, they're the same, and cancel those out. Those are gone. There is no I. All right, so from here, I think most of you went ahead and then simplified, did factor trees, right? So we did 4 and 10, 2 and 2, 2 and 5. So you came up with 2 radical 10. 6 doesn't really do anything. I think this is the majority of you, this is the path you took. And then from there, you rationalize your denominator. So you multiplied top and bottom by radical 6. So we had 2 radical 60. Radical 6 times radical 6 is radical 36, which is just 6. What about from there? Mm-hmm. Yep. I can do 2 and 6 and both be divided by 2. So radical 60 over 3. What about that radical? I can break that down again. So I end up with a pair of 2's. Left over 3 and 5, so 15. And then over 3. And I'm done. Now that was one that had a lot more simplifying at the end. So that I think is the way most of you did that problem, which is fine. It's beautiful. Can I show you one other option? There's a lot of other options that are longer. Let me show you an option that's a little easier, okay? From the beginning, I said to simplify. So if I kind of pick up here, where my I is already canceled, and I have 40 over 6, does that simplify? 40 over 6? If you had 40 over 6 as a fraction, would you simplify it? Can divide them both by 2? Mm-hmm. So radical 20 over 3. Is that fair? Yeah. I'm just simplifying 40 over 6. They're both under radicals. I can simplify those. Then I can do a factor tree here. So that would have given me 2 radical 5 over radical 3. And then I can rationalize this. So I get 2 radical 15 over 3. Look at my work in blue versus my work in red. I got there. I mean, there's so many different ways you guys can attack these. You really can. But the more simplifying you do early, the easier it's going to be for you. Now, let's say you didn't recognize it right away and I turned my 40 into the 2 radical 10 like I did here. Could I simplify the 10 over the 6? Yeah, I still could there too. Okay, at any point, if they're both under radicals of the fraction, you can simplify them. Question? For this part? We simplified here. I changed 2 over 6 to 1 over 3. Yeah, that was suggested to go ahead and do that there. If not, you would have done it at the end and would have simplified still at the end of it. Okay, so there's different ways. So if you're doing it one way and you look at your partner next to you and you're like, what are you doing? Like they just may be taking a different route, okay? As long as both are underneath a radical, you can simplify those. Me personally, I simplify as far as I possibly can before I even dream of rationalizing. I want to make my numbers small, okay? And I'm lazy, and that's less work. That's really what it boils down to. All right, questions on dividing and rationalizing. Did anyone not write down your 4 steps? Good, awesome.